All right, in this lesson, we're going to talk about how to solve systems of equations by substitution. The last lesson, we solved the systems of equations by graphing the equations and then finding the point that the two lines crossed. And that was the x and y value that makes both equations true. And so by this method, we substitute the one equation into the other equation. And if you remember the last equation, we had used Desmos to do the graphing. In this lesson, we're not going to use Desmos, and because we're not graphing. All right. So there's the 5 basic steps. You solve for one of the variables in at least one equation if that's necessary. All right. So sometimes one of the variables is already isolated in one of the equations, or maybe even in both equations. All right. But if not, you need to solve for one variable in one of the equations anyway. And then you substitute that resulting expression into the other equation, solve it to get the numerical value for that first variable. Once you find out the numerical value for the first variable, you plug that into the other equation. Actually, you can plug it into either one of the two equations, and you solve it to find out the value of the second variable. And the last thing then is to write it as an ordered pair, x and then y. So let's do some examples. Oh, and by the way, make sure you copy all 5 of those steps down into your notes, please. All right, so you solve by using substitution. And we notice here that we already have y is equal to 7. So when we're looking at this, remember we're looking at x and y. That's the ordered pair. So when we look at that, we're already told that y is 7. So the first 3 steps are already done. And so because we have a variable isolated, and then we have a numerical value for that variable. So we know that y is 7. So then all we have to do is take this 7 and plug it in for the y in the second equation. So we're going to say x plus 7 is equal to 3. All right. So the x, we haven't done anything with the x. That's what we're trying to figure out. And then the y becomes a 7 because of that up there and 3. So using inverse operations, the inverse of adding 7 is subtract 7, subtract 7. So 7 minus 7 cancels out. We're left with x is equal to -4. So my x value is -4, and the solution is -4, 7. Got another one. All right. It's slightly more complicated, but the same basic premise. So here we said that y is equal to 5. So once again, we're given the fact that y is 5. Sometimes it won't be y is equal to 5. Sometimes I'll tell you that x is equal to something. Okay? But in this case, we're said that y is equal to 5. So what that means is we're going to plug in a 5 everywhere we see a y. So we have 2x plus 4 times y, but instead of a y, we're going to put in a 5 is equal to 26. And then we just solve this, okay? So simplify it. 2x plus 20 is equal to 26. All right. Solve it. Inverse operations of plus 20 is minus 20, minus 20. So we end up with 2x is equal to 20 take away, or 26 take away 20 is 6 divided by 2. X is equal to 3. And so we say that our solution is 3, 5. All right. All right, so a little bit more complicated on yet on into that. You know how it goes. You start off easy and get more complicated. So here we have both equations are solved for y. All right, so we have y is equal to 5x plus 9, and y is equal to negative 4x plus 27. Well, so basically all we have to do is we're going to say these y's are the same thing, okay? So we're going to say this 5x plus 9, I'm going to plug it in for the y in the in the other equation. So instead of the y, I'm going to put 5x plus 9 is equal to, and I'm just going to bring this other half down, 4x plus 27. We're going to solve. All right. So using inverse operations, and I always move the variables first, and I always move the variable with the smallest coefficient first, so that's negative 4. So the inverse of negative 4x is plus 4x, or a positive 4x, and positive 4x. Negative 4 plus 4 cancels out. 5 plus 4 is 9. X plus 9 is equal to 27. Inverse operation, minus 9, minus 9. So 9x is equal to 18 divided by 9. Cancels out. 9 over 9 is 1. 1 times x is x. X is equal to 2. Okay? So we know that our x value is 2. We don't know what our y value is, but we do know that y is equal to either 5x plus 9 or y is equal to negative 4 times x plus 27. So we can plug this 2 into either one of these two equations. I'm going to plug it into the first one because it looks easier. So I'm going to say y is equal to 5x plus 9. And instead of the x, I'm going to say the value of x is 2. So that's 5 times 2 plus 9. All right. And y is equal to 10 plus 9, which is 19. So y is 19. All right. So the solution is 219. Another one that's very similar to the one we just did. Both variables both equations are solved for y, and it's not always going to be solved for y. Sometimes it may be solved for x, okay, where you have the x isolated. But in both of these equations, we've had the y isolated. So once again, we're going to take this 2x and we're going to substitute it in for that y there. So we're going to say 2x is equal to x plus 5. Remember that if there's not a number in front of the x, that's understood to be a 1 there. Okay, so now we're just going to use inverse operations. Minus 1x minus 1x. 1x minus 1x cancels out. 2x minus 1x is 1x is equal to 5. And 1 times x is just x. So x is equal to 5. Okay? So we know our x value is 5. All right? Then we're going to plug it into either one of these two equations. They're both pretty easy. I'm going to plug it into the top one. Okay? So I'm going to say y, because that's what we're looking for. Y is equal to 2 times x, or our value of x is 5, so it's 2 times 5, which is 10. So y is equal to 10, so our solution is 510. All right. Another solving by substitution. You notice here that we only have this second equation is the only one that has the y or has any variable isolated. All right. So we're going to take this y here, this y is the same as this y. So we're going to say 2x plus y is equal to 5. But instead of the y here, I'm going to plug in the expression for the second equation. So it's 2x plus x minus 4. That's from over here. Okay, that's over here. It gets plugged into over here, is equal to 5. All right. Now, when we split it, before we can use inverse operations, we're going to collect like terms. And the 2x plus x are like terms that are on the same side of the equation. All right. So we're just going to add them together. 2x plus x is 3x minus 4 is equal to 5. Add 4 to both sides. We're left with, this cancels out, 3x is equal to 9 divided by 3, and x is equal to 3. All right, so my x value is 3. Then I'm going to take that x value, and we could plug it into the top one, okay, and solve it that way, but it's easier to plug it into the second one here. It's easier to take that 3 and plug it into that because it already says y, which is what we're looking for, y is equal to x minus 4. All right. We're told that x, we found out that x is a positive 3 minus 4. And so y is equal to 3 take away 4 is negative 1. So the solution is 3, negative 1. All right. No, that was the last problem. Okay, so if you have any questions, make sure that you ask me whenever you see me, and we'll talk to y'all later on.